Hi everyone, it's Miss Costa here, and in this video I'm going to go through a higher practice paper in the style of the AQA syllabus and questions for Thursday's exam. Okay, so for the first question, it's a simple BIDMAS question, and the key thing to remember is to do things in the order of operations. So we know that we have to do with BIDMAS, we do anything that's in brackets first. So I'm going to do 13 squared divided by, and this is what I'm going to work out first. So a quarter times by the square root of 64, which is 8. I do the root of 64 because indices is the second thing that comes up in BIDMAS, and you have to do it in order. So first you look at the brackets, you do the thing that's in the indice, and then we keep going. So I keep everything else as it is because the order needs to stay the same. So a quarter times by 8, a quarter times by 8 becomes 8 over 4, which is 2. So that becomes a quarter, nope, that's what I've just done. That becomes 2. And then I can just work from left to right because I'm just left with division. So 13 squared is 169 divided by 2. I can just use my short division. So 2's into 16 go 8, 2's into 9 go 4, remainder 1. I've run out of numbers, so I'm going to put zeros there. 2's into 10 go 5 times, so therefore the answer is 84.5. Okay, now I am told that I want to work out the size of an exterior angle of a regular octagon. So an octagon is a regular shape with 8 sides, and there's something that you need to know about exterior angles. So if you just think about any shape, let's take a triangle. If we keep shrinking it, eventually it just forms a little dot. And what do I know about angles at a point? I know that angles at a point must always sum to 360 degrees. So that must mean if I look at all of these exterior angles, and the exterior angle, this is another thing that people sometimes get confused, you've got an interior angle and an exterior angle, and they sum to make 180 degrees. So it's when you continue the line of the side on, what's this angle here? That's what I'm looking for. So again, if I did it with this, can you see how eventually it shrinks down and you're just left with angles at a point? So that's why all exterior angles of any shape are going to sum to 360. So exterior angles sum to 360 in any polygon. So I know that there are 8 sides, which means there's going to be 8 exterior angles. So what I need to do is 360 divided by 8. I mean, we could do this using short division as well, or we could have simplified, whichever you find easier. So 8's into 36 go 4, remainder 4, 8's into 40 go 5. So that must mean that one exterior angle is 45 degrees. Okay, in this question I have been given 2 points. A is the coordinate 4, 0, and B is the coordinate 0, -6. And I need to work out the midpoint of AB. I could just draw a quick sketch if I wanted to visualize it. So A is 4, 0. Remember the X coordinate always comes first, then the Y coordinate. So 4, 0 would be here. B is 0, -6, so it would be somewhere over here. And I need to work out what the midpoint is. So to work out the midpoint or the middle of any two numbers, you always add them together and then divide by 2. So we do that with our X coordinates first. 4 plus 0 divided by 2 is 4 over 2, which is 2. So the midpoint's X value is going to be 2. And for Y, we do 0 plus -6. So 0 minus 6 is -6, divided by 2 is -3. And then let's just check if that makes sense. Well, yep, here I've got 4, 0, here I've got 0, -6. And does it make sense that the midpoint is going to be 2 and -3? Yes, because that is halfway. So your midpoint would be 2, -3. Okay, so a multiple choice question. And with multiple choice questions, actually sometimes the hardest questions because they're trying to draw out and see if you will get fooled by the misconceptions. So actually work it out. Don't just look at it and think, I'm going to pick that one. So we're trying to circle the correct statement. And what is an identity? It's something that has 3 little lines in the middle of it, and each side must simplify to the same thing. So for example, when you collect the like terms, they're both going to look the same, or if one's in a bracket. So like, let's say 3x plus 3 equals 3x plus 1, because if I expanded that, it's the same. So that's what an identity is. So let's have a look and see what's happening here. 5x equals x plus 4x. Is that true? When I collect the like terms, does 5x equals 5x? Yes. So actually, I've already identified the correct statement. I know that 4x and 2, they are not identical. 5x plus x would be 6x, and 7 take away x does not make 6x. And here you've got 6x minus 3 equals 0. This is just an equation that can then be solved, but that's not the purpose of an identity. So your identity is going to be this thing here. Whenever one side simplifies to the same thing on the other side, that's when you know it's an identity. Okay, so here I've got a question that asks me to work something out and give my answer in standard form. So I've got 160 million divided by 400. I can write it as a fraction and cancel out the zeros. So divide by 10, and then it would be 160, 1, 2, 3, 4, 5. So that's 16 million divided by 40, divide by 10 again. It would be 1.6 million. So chop off a 0 again. We've got 6, 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 divided by 4. Then I can just use short division. So 4s into 16. 1,600,000. 600,000. 4s into 1 don't go. 4s into 16 go 4. And then all of the zeros are just going to remain the same. So I'm left with 400,000, and I need to write this answer in standard form. So standard form is going to be a whole number, single digit whole number, so in this case 4, times 10 to the power of something. And what you do is you just count how many digits after the first number. So you've got 1, 2, 3, 4, 5. So that would be 4 times 10 to the power of 5. Okay, so in this question, I'm told that Hanan's age is 2 years and 6 months, and Sophia's age is 1 year and 4 months. And I need to write Hanan's age in months as a fraction of Sophia's age in months. So the key thing here is I'm told that I want to be dealing with the ages in months. So that's the first thing that I'm going to convert. So 2 years, I know that in 1 year, there are 12 months. So 2 years is going to be 24 months plus 6 months for Hanan. And then that would give me 30 months. Then Sophia's age is 1 year. So that's 12 months plus 4 months, which is 16 months. So I need to write Hanan's age in months as a fraction of Sophia's age in months. So I'm just going to write that as 30 over 16. And it says write your fraction in its simplest form. So I'm just going to keep simplifying. So first I can start by dividing by 2. So it'll be 15 over 8. And nothing goes into both of them. So it will just remain as 15 over 8, but I probably will want to turn it into a mixed number. So 8s into 15 go once, remainder 7. So it'll be 1 and 7/8. Okay, so in this question, we're dealing with a Venn diagram. I'm told that there's some information about 90 people who play musical instruments. 15 play cello, but not violin. 30% play neither, and a quarter of the violin players are also cello players. I'm asked to complete the Venn diagram to represent the information. Now, this little sign, you may not be super familiar with set notation, but that just means the universal set. You don't need to know that but you need to understand what it represents. So the universal set means everything that exists inside this Venn diagram. That's why the universal set is out there. So everything that exists in this Venn diagram is the universal set, which is 90 people who play musical instruments. So that means that this Venn diagram here is going to need to add up to make 90 people. Now C is for cello players and V is for violin players. So here you're going to fill in your cello players and here your violin players. So let's see what we can do with the information that we've been given. So first of all, I know that 15 people play cello, but not violin. So that would be everything inside this little bit here, because this, the whole circle is cello players, but this bit is the intersection between cello and violin. So only this bit can be people that play only cello. So I would write 15 in this part here. Then I'm told that 30% play neither cello nor violin. So that's going to be everything outside here, because these people out here don't play cello or violin. That's reserved for inside the Venn diagram. So let's work out 30% of 90. So 10% of 90 is 9. To work out 10%, the shortcut is you just divide by 10. And 30% would therefore be, if I multiplied that by 3, 9 times 3 is 27. So 27 people are going to be sitting outside here. It then says that a quarter of the violin players are also cello players. So that means that whatever exists in here, a quarter of the violin players are also cello players. So this is going to be 3x. You don't need to turn it into algebra, it will be quite straightforward if we go through it. So let's figure out what this and this must add up to, because in your Venn diagram, everything needs to add up to 90. So we've got 15 plus 27. 7 plus 5 is 12, 2, 3, 4, so that's 42. 7 plus 5 is 12. Okay, so this, been a long day. So this and this sums to 42, which means if I subtract 42 from 90, I'll be left with what must remain over here. So 90 take away 42 is going to give me 48. So I know that these two must sum to 48. And it tells me that a quarter of the violin players are also cello players. So a quarter of 48 I could work out, and that's 12. And therefore 3/4, 3 lots of 12 must be 36. So you didn't need the algebra part there, but if you find working with algebra easy, then it could have been helpful. So that is our Venn diagram all completed. Now to double check that you've done it right, you would probably just want to add everything up and make sure it sums to 90. Okay, in this question, I'm asked to write a calculation as a single power of 3. Now this is really important because it's basically given you the biggest hint that you need. So this is already a power of 3. So it's 3 to the power of something. This is the base, and that's the power. So all I need to do is simplify. Now with the law of brackets, whenever you've got brackets, you multiply the indices. So that would become 3 to the power of 12. And 27, well, let's think about what happens with 3 and its powers. So 3 to the power of 1 is 3. 3 squared is 3 times 3, which is 9. And 3 cubed is 3 times 3 times 3, which is 9 times 3, so that's 27. So I know that 27 can be written as 3 cubed. And now what's left is to simplify this. So when I'm multiplying indices, I add the powers. So that becomes 12 plus 3. So that would become 3 to the power of 15. Okay, so this is a super fun question, and it's one that frequently people just get wrong. Not the whole bit wrong, but they just miss one tiny little bit. So hopefully you didn't let this question fool you, but let's see. So I'm told that a shaded semicircle is inside a circle as shown. Oh my goodness, that should have said shown. The radius of the circle is 12 centimeters and the diameter of the semicircle is 8 centimeters. And I need to figure out how many times bigger the unshaded area is than the shaded area. So I'm going to want, and I would recommend for questions like this, you just lay your working out really nicely and you label different sections as to what you're going to want to work out. So I'm going to need to work out what the unshaded area is and also what the shaded area is in order to compare them. So I'm just going to put that there, and let's see when we reach it. So in order to work anything out, let's just remind ourselves what the formula of a circle is in terms of working out the area. So the area of a circle is pi times by radius squared. So you're always looking to locate the radius. And this is a non-calculator question, so we don't need to worry about what pi is. We just leave everything in terms of pi. So let's work out the area of the big circle first. That's going to be pi times by 12 squared, which is 144 pi. So I'm just going to leave that as 144 pi. I don't need to do anything else, and that's the benefit of non-calculator papers. Now, I need to work out the area of the semicircle. So this is frequently where people just forget to do one of two things. So it's the radius that I'm looking for. So it's helpful to annotate. So I know that the radius is half of the diameter. So the area of the semicircle is going to be, if I imagine this is a full circle, I can do pi times 4 squared. But because it's a semicircle, I then need to divide it by 2. So that would be 16 pi over 2, which is 8 pi. So now I have my two little bits. So I've got the circle. Imagine if it's the full circle, which is 144 pi. And then I've got the shaded area, which is 8 pi. But to work out how many times bigger the unshaded area is than the shaded area, I need to actually work out what the unshaded area is. And this is the bit that most people just forget because there's so much going on here. So what do you need to do to work out the unshaded area? You're going to do the area of the big circle, so 144 pi, take away whatever the shaded bit is, which is 8 pi. So therefore, the unshaded area is 144 minus 8, which is going to give you 136. So the unshaded area is 136 pi. The shaded area still remains the same because I haven't done anything to it. So let's figure out how many times bigger it is. So let's get rid of all of this working here. So there's a few ways you can do this. You could do 136 divided by 8 to figure out what you multiply by. So actually, yeah, let's just do that. 136 divided by 8. 8s into 13 go once. Remainder 5. 8s into 56 go 7. So it is 17 times bigger. Okay, so hopefully you managed to get that. A lot of people get caught on the they just forget to subtract the shaded area bit. Okay, so in this question I'm asked to work out the percentage increase from 60 to 420. So what I want to do in order to work this out is well, there's a few things that we can do. If you want to just do it in terms of percentage change formula, so the percentage change to work out percentage increase or decrease, what we do is we write down, we figure out what the new value is. We subtract the original value divided by the original, and we multiply by 100. So in this case, the new value goes from 60 to 420. So do 420, take away the original, which is 60, over the original, which is 60. And 420 take away 60 is 360. 360 divided by 60 is the same as 36 over 6, which is 6. So when you get this, it's going to be needing to be times by 100 as your final part. So the percentage increase is 600%. Okay, so here I've got a nice algebraic reasoning question. I'm told that a large rectangle is made by joining 3 identical small rectangles as shown. And the perimeter of one small rectangle is 18 centimetres. Because I know that, I then need to work out the perimeter of the large rectangle. So what would be good is, I mean, I just think algebra is always going to simplify your life. You could be doing trial and error, but that might be a little bit more time consuming. So if this is a rectangle, I know that I can call one of the sides X because I don't know what it is, and the other side Y. But because we're dealing with perimeter here and opposite sides of a rectangle are equal, I know I'm going to have 2 lots of X and 2 lots of Y. So the perimeter of one small rectangle is 18 centimetres. So I know that 2x plus 2y must equal 18 centimetres. And again, you could do trial and error, but you might notice something here. So if I've decided that all my sides are going to be X and Y, I can start like actually writing that in. So this is going to be X, this will be X, this would be Y. Actually, let's do them in different colours. Y, X, and X. Hopefully you realise that the length of one of the small triangles is equal to the width of 2 of the small triangles. So you know that Y equals 2x. Now, because it's 18 centimetres, there's only a limited amount of possibilities that you could do. So you could be trialing it and being like, okay, well, I know 6 times 3, 9 times 2, and try and figure it out that way. Or we know that Y is equal to 2x. So wherever I see a Y, I can substitute 2x. So 2x plus 2 lots of 2x must equal 18 centimetres. Oh, I realised I could have done something easier, but yeah, okay. So we could do that, or let's spot the easier thing. Y equals 2x. So every time you see 2x, you can replace that with a y. So let's do that. It just makes our working a little bit simpler. So y plus 2y is 18. Therefore 3y is 18. Therefore y must be 6. And if y is 6, x must be half of that, so x would be 3. Now you need to work out the perimeter of the large rectangle. So either you could put it into your algebraic formula where you know that you've got 3y plus 1, 2, 3, 4x, and you just do 3 times 6 plus 4 times 3, which is 18 plus 12, which is 30. Or you could have literally just written it here. So every time you see a y, you could have written in 6. And every time you see an x, you could have written in its value, which is 3. All methods work, but the end result is the perimeter of the large rectangle is 30 centimetres. Okay, in this question, I'm specifically told to use approximations to one significant figure to estimate the value of this calculation here. So when I'm approximating, I'm just roughly making my numbers as easy to work with as possible so I can make a quick guess as to how much of something I might need. So I'm rounding to one significant figure. So I've got 0.496. To one significant figure, I'm going to circle the 4. Look next door and round it to the nearest value. So because it's more than 5, I'm going to round it up. So that would become 0.5. I'm going to look at the next thing, which is 40.45. So once again, look at the first significant figure. The next digit is less than 4, so this is just going to remain as it is. And with significant figures, 40, you don't need to write 40.00 because that's the same thing. And then you've got the square root of 24.95. So the square roots are normally, there's a little trick that we can do. You just think to yourself, what are the square numbers? So you know 1, 4, 9, 16, 25, 36, and so forth. And then you think which square number is this closest to? So this would be closest to 25, but also to one significant figure, it rounds to 25. So now I've got all of my values. I'm going to calculate it. So really, really, really important. You need to round everything before you do any of your work. If you actually calculate this calculation, you get nothing. So I've got 0.5 times by 40 squared over the square root of 25. Now 40 squared is just going to be 40 times by 40. So how would I do that? 40 times 40, you do 4 times 4, which is 16, and then add on this 2 zeros. So you've got 0.5 times by 1,600 divided by the square root of 25 would be 5. Now, multiplying by 0.5 is the same as multiplying by a half. And when we're multiplying by a half, what are we actually doing? We're dividing by 2. So this is just a little trick that is just going to really help you with non-calculator paper. Dividing or multiplying by 0.5 or a half is the same as dividing by 2. So a half times by 1,600. The reason for that is because this would become over 1, and you multiply 1,600 and you multiply 2 times 1. So that's 800. So our numerator is going to be 800, and then I need to divide it by 5. So I can just do that using short division. So 800 divided by 5. 5's into 8 go once, remainder 3. 5's into 30 go 6. So that would be 160. Okay, so this is another question that is just so good for teasing out misconceptions. So pay attention carefully if this is something that normally catches you out. So I need to circle the volume that is the same as 8 centimeters cubed. So whenever we're dealing with converting metric units, which is when we're turning like meters cubed into meters squared, or dealing with area and volume, not just length, it's very important that you think about what's happening. So if I think about a centimeter as a length, yes, 1 centimeter is equal to 10 millimeters. And all the answers are in millimeters cubed, so I know that it's the millimeter conversion that I want. But if I turn it into an area, what's happening? Well, 1 times 1 still remains 1, so it will still remain 1 centimeter squared. But with the millimeters, what is happening? Well, 1 centimeter is 10 millimeters, so I'd have to do 10 times 10, which means that 1 centimeter squared is equal to 100 millimeters squared. And then, because we're dealing with volume, what do we do again? We multiply by another dimension. So you'd actually do 1 times 1 times 1, which is 1 centimeter cubed. But for our millimeters, we're multiplying by another 10. So that would actually be 1,000 millimeters cubed. So 1 centimeter cubed is 1,000 millimeters cubed. So if I had to work out what 8 centimeters cubed would be, I'd have to multiply by 8, and that would be 8,000 millimeters cubed. This always catches people out because they think they know that 1 centimeter is 10 millimeters, so they just time by 10 and they would have circled this, but that is how they catch you out and you lose a sad little mark. Okay, so here is an inequality, which is generally quite straightforward, but the issue here arises, and this is another thing that people forget so often, is that when, I'm going to write it down because people forget it so often, when you are multiplying or dividing by a negative number, the sign, so this sign flips over. So this is a key piece of information that people always forget, and then they just lose this mark because that's what it was testing. So what is happening here? We know that minus 3x is greater than 12. What are we going to do? We're going to be like, okay, I'm going to divide by negative 3. Very simple. But as soon as with an inequality you multiply or divide by a negative number, the inequality sign flips over. So that would become x is less than whatever this result is, 12 divided by -3. So x is less than -4. People always forget this. I won't explain why. If you really want to know, let me know and I can make a video. But just make sure you write a little note about this, because it's another great way that they can catch you out. It only applies for when you're multiplying or dividing by a negative number. Anything positive, the inequality sign stays the same. Okay, so in this question, I am told that there's a meal deal offer on. You can choose 1 sandwich, 1 drink and 1 snack. There are 8 different sandwich options, 3 different drink options and 5 different snack options. And you need to know or work out how many different meal deal combinations there are. So with combinations, how many options do I have for my first thing? I would multiply that by how many options I have for my second, and then how many for my third. So in this case, I've got 8 different sandwich options, 3 different drink options and 5 different snack options. So 8 times 3 is 24, and then 24 times 5, I can do the doubling and halving method, where if I double one part of the calculation and halve the other, the answer will be the same. So that's 120. Okay, and for the next part of the question, it says that 4 of the sandwiches have ham in them, 3 of the snacks have chocolate in them, and Emilios picks a meal deal at random. So I need to work out the probability that the sandwich has ham in it and the snack has chocolate in it. So this and is underlined in bold. Remember, with the and rule, when we are trying to work out the probability of this and that happening, we multiply. So 4 of the sandwiches, it's 4 over 8 is the probability of having a ham sandwich. And how many snacks were there? 5. And 3 of them, 3 out of the 5 have chocolate in them. So if Emilios was to pick a meal deal at random, we would have to work out these probabilities and then multiply them, because it's the probability of this and that happening which minimizes the probability. So 4 times 3 is 12 and 8 times 5 is 40. So that is your answer. Because it's probability, we don't need to simplify the fraction at the end. You can if you want to. It would be 6 over 20, 3 over 10, but you don't need to. You'll still get the marks even if it's in its unsimplified form. Okay, so in this question, I'm told that the value of y is 40% more than the value of x. So what I want to do is express y in terms of x. So I know that if x was whatever, it was just x, y is going to be 40% more than it. So y is going to be whatever x is times by 1.4. The reason it's 1.4 is because the original value is x, which represents 100%, and then if I added on 40%, that would be 140%, and percent means out of 100, so divided by 100 is 1.4. So anyway, the multiplier would be 1.4. So 1 lot of y is 1.4 lots of x. So if I multiplied by 100 to just make my numbers nice and easy, I know that 100 is equal to 140. So it would be in that ratio. And then I could divide by 10. So 10, sorry, I don't know why I'm making it equal. So it would be 100 to 140, 10 to 14. And then I could simplify that to 10 to 14. The ratio, if I divide by 2, would be 5 to 7. So it would be the first ratio. Remember, with the multiple choice questions, always actually work it out, because the answers in there are deliberately designed to kind of trick you to see if you're just trying to get the quickest answer without actually thinking it through carefully. So that is how we'd do that kind of question. Another way is that you could have just actually worked it out. So 5 to 7, you could have done equivalent ratios would be 10 to 14, and you'd be like, okay, well, I know that 10 times 1.4 is 14. There are loads of ways you could have done this, but the answer would have been 5 to 7. Okay, so here we've got a negative fractional indice. So the key thing to remember for negative indices is that you want the reciprocal of it. So for instance, if you had 5 to the power of -1, that is 1 over 5. If you had 3 to the power of -2, that is 1 over 3 squared. It's the reciprocal of whatever the power thing is. So if we imagined we took away the minus, that would just be 5 to the power of 1, but the reciprocal would be 1 over that thing. This, if we took away the minus, would be 3 squared, but the reciprocal is 1 over 3 squared. Now when we come to fractions, the reciprocal is a little bit easier. You just flip the fraction over. So that would be 3 over 2 to the power of 3 in this question. So let's do that. So that would be 3 over 2 to the power of 3, which means each individual part, the numerator and the denominator, are being cubed. 3 cubed is 27 and 2 cubed is 8. And that would be the exact value. It doesn't say simplify your fraction, so we could just leave it as that. Okay, so in this question, I've been given an algebraic fraction and I've been asked to simplify it fully. So generally with algebraic fractions, the trick is you're going to try and factorize numerator and denominator and find something that's common to both so that they can cancel out. So we're going to try and do that here. Now, normally it's going to be a quadratic and it's going to factorize into 2 brackets, but here it's slightly different. So let's see how we can factorize the numerator. It's not the difference of 2 squares, so we're just going to factorize it as a single bracket. So the highest common factor of 5x and minus 10x squared is 5x. So that would be 1 minus 2x. That's my numerator. Then my denominator, the highest common factor is 7. So I take that out of the bracket and this would become 2x minus 1. Now, normally what you'd see is a bracket that is the same on the numerator and the denominator, but here, unfortunately, that isn't the case. But hopefully you notice that they are the inverse of one another. So essentially, the negative version of one another. So what I could do, and this is the trick that most people miss, is I could factorize out this. I could factorize out -1, because then that would turn everything inside the bracket the opposite, the inverse. So if I took out -1 outside this bracket, then this would have to become -1. And here, -1 times by +2 gives me -2x. So I've just factorized out -1. Now, let's try and think about how that could relate to doing this a little bit differently. So you notice that they're the inverse. So you're like, okay, I need to do things differently. So we want our 2x to be positive. So actually what we could do is factorize out -5x. And then what happens is you've got -1, because a negative times by negative gives you a positive. And then here you would have +2x. Okay, so we're just playing around a little bit with it so that the 2 brackets can match up.
I don't understand.
So, I mean, if this doesn't make sense, it doesn't make sense to Siri either, so don't worry. It is quite tricky, but now hopefully you can see that you've got the top bracket that is the same, and writing 2x minus 1, we can just write it a little bit neater so that but it means the same. -1 plus 2x is the same as 2x minus 1. So now the numerator and the denominator have a bracket that can cancel out, and you would be left with -5x over 7. Or you could write it as -5/7 x, whichever is absolutely fine. But that's the little trick. So whenever you notice all these brackets are the same except kind of opposite, and factorize out a negative from the bracket. Okay, so here we've got some iteration. So iteration is essentially where you keep putting an improved answer into your formula, equation, whatever it is that they've been given, and you keep getting closer and closer and closer and closer to the real answer. So people generally, once you understand iteration, it's very simple, but the bit that people get really confused by is these whole terms here and what they mean. So essentially every iterative process has a first term, which is U1, a second term, which is U2, a third term, a fourth term, and a fifth term. That's what the little number to the bottom left stands for. So U1 tells you essentially the first term, okay? U2 will be the second term, or second value, not term, because it's not a sequence, but the first value, let's say, okay? And third value, fourth value, and so forth, okay? And in this question, you are being asked to work out the values of U2 and U3, so the second term and the third term, and you've been given the first term. Now, what this next bit here means, so you're generally going to have something like this, UN and then UN plus 1. This just means the original term, and this just means the term after the original term. So it will hopefully make a little bit more sense when we put it into action. But this is the general formula, okay? So UN plus 1, the term after the original, is going to be 10 over the previous term minus 1. So that's another way of doing it. We could say UN plus 1 is this term, and UN is actually represents the previous, and why do I keep saying term? Value. Okay, so if I'm trying to work out U2. So U2 is going to be 10 over UN, 1 less than that, which is U1 minus 1. They've told me what the value of U1 is. So U2 is going to be 10 over 6 minus 1, okay, which is 10 over 7. So it makes a lot more sense once you start doing it. Having to explain it, it's much simpler just seeing it and realizing what it means. But it's this little bit that confuses everyone, and that's the bit that you need to try and wrap your head around. And then once you do, it's actually very simple. So we've worked out that U2 is 10 over 6 minus 1, which is 5. I don't know why I wrote 7. This is why you redo things carefully and check our working. So 10 over 5 is 2. So that must mean U2 is 2. And then U3 is going to be 10 over the previous term, which is 2. 2 take away 1. So 2 take away 1 is 1. So that's the same as 10 over 1, which is 10. Okay. So that is literally all iteration is. You're putting in the previous thing, your previous answer. This is your previous answer, and you're putting it in to find the next term. So just to recap it one more time. So U1 we know is 6. U2 is going to be 10 over 6 minus 1. Okay, I've put that in here. And then U3, which is, we decided that was 2. And then U3 is going to be 10 take away 2 minus 1. So you're constantly putting in the previous term, okay? And that's all iteration is. You're putting that into the formula and getting closer and closer to the answer. Okay, so here is another very, very simple question, but one that people just tend to rush through. So what is density? It's helpful if we know the formula. Density is mass over volume. Okay, so if we know that, we're always going to be able to figure out what a unit of density is, because the first bit, so it's like mass over volume. Okay, so what are units of mass? Well, grams, kilograms, anything like that. What are units of volume? Centimeters cubed, meters cubed, anything of that sort. Okay, so volume is something to the power of 3 because it's 3 dimensions that are being multiplied. So the only thing that could possibly be representation of density, volume has to be the second part. So that's not volume because that's grams, that's mass, and that's area. So the only possible thing that could be is grams over centimeters cubed, because grams is a unit of mass and centimeters cubed is a unit of volume. Okay, so here we've got a vectors question. Now there are just a few rules that are super important for vectors, and if you know them, then you'll be able to do the majority of vectors. So the first is that when we're doing a question like this, we have to almost imagine that like the vectors that are labeled are paved, created roads that you can actually drive on. Anything else is like a random field with lots of mud in it and it's undrivable. You can't drive through that. We just can't drive through unrouted, unpaved ways. So when we're dealing with vectors, we can only go along routes that have already been labelled. So for example, here, if I wanted to go from E to H, I can't go across here because this is the muddy random field that I can't go on with my little vector car that I don't know what that is. But anyway, the point is that I cannot go through unnamed routes. I always have to go through the named roads, even if it seemingly makes my journey longer. So here, to work out EH, for example, what you do is you start from E and then you have to go through your named routes. So here you've got this vector here that is 3a plus 2b, and then you can go through this vector here, and that is how you work out EH. If you had to work out well, you can't. If you had to work out GH, okay, even though GH is just this bit here, we would have to go along the given routes. So GH, you would have to go along here, then along here, then along here. Okay, so you have to go along the named paved roads. Imagine everything else is like a boggy, marshy, undrivable field. So now I've lost my train of thought. Okay, so let's apply that to this question. So I'm told that the vector FG, so this vector here, is 3 lots of EH. Okay, so if that is the case, then these two vectors are parallel because parallel vectors are multiples of one another. But I don't think that's needed for this question. We'll find out. So I need to work out FE in terms of A and B. Again, how can I work out FE? Well, I'm going to need to figure out something so that I can go along a paved way. So let's think. They've given us a little clue here. FG is 3 lots of EH. So the first step would be to work out what EH is. Now, if we do the method that I told you, so to go from EH, we start from the first letter, go to the next one. So we start from here, we go along this route, which is 3a plus 2b. And then we go along this route here, which is 5a plus 3b. Now, as long as we're going in the direction of the arrow, the vectors stay the same. If we reverse the direction of the arrow, then we reverse the signs. So like if we were going this way, it would be minus 5a minus 3b. But we'll come back to that in a bit. So the vector EH is going to be, collect the like terms, 3a plus 5a, which is 8a, plus 2b plus 3b is 5b. So the vector EH is 8a plus 5b. So I could write that on here as something that I've worked out, and I know that this is 8a plus 5b. Now the reason this is important is because I know that FG, so going in this direction here, is 3 lots of AH. So FG is going to be 3 lots of 8a plus 5b. So that gives me 24a plus 15b. So the vector FG is 24a plus 15b. So let's have that here, 24a plus 15b. Now all that working I'm just going to rub out so that I have a little bit more space. But it's all written on this diagram now. Now I need to work out FE in terms of A and B. So once again, I've worked out everything that I can using the information the diagram has given me, and I need to work out FE. Remember, I start from F and I want to get to E. I cannot go through this unpassable land because it has not been labelled. I don't know. There's no route. It's just a boggy random mess. I have to go along the designated like roads I've been given on my vector journey. So I'm going to go along here. So So how do I get to FE? The journey I would take would be I'd go from F to G plus G to E. Now this is where it gets a little bit trickier because I know that EG is 3A plus 17B, but remember when you're reversing the direction, so I'm going in this direction, so I'm going to need to reverse the direction of travel. So GE is going to be minus 3A minus 17B. So then I can take that vector journey and write out what its values are. So 24A plus 15B, and then GE is minus 3A minus 17B. So what's happening there? You've got 24A minus 3A. So 24 take away 3 is 21A, and 15 take away 17 is minus 2B. So there we've got it. The vector FE is 21A minus 2B. Okay, so in this question, I am dealing with the equation of a tangent to a circle. Or rather, I'm dealing with a tangent to a circle, and I'm most likely going to want to work out its equation in order to work out an x-coordinate. So let's think about all the information that I've been given. So 5, 10 is a point on a circle, centre O. So when x is 5, y is 10, because the coordinate is always x and then y. And I know the tangent at 5, 10 intersects the x-axis at P. Work out the x-coordinate of P. Okay, so there's a lot of things that I can do here. So first of all, I am going to need to work out what the equation of this line is, because that's the only way I could figure out what the P coordinate would be. So to work out the equation of a tangent, generally what we do is we first of all work out the equation of the radius of the circle, because if we do that, we know that a radius and tangent meet at 90 degrees using circle theorems. That's just something that we need to know. So a radius and a tangent always meet at 90 degrees, which means they are perpendicular lines, which means their gradients are negative reciprocals of each other, so they multiply to make minus 1. So let's have a look at how I could work out the gradient of the radius. So the gradient of the radius is going to be the difference in the y value over the difference in the x value. Gradient is change in y over change in x. So the change in y is 10, the change in x is 5. So the gradient of the radius is 10 over 5, which is 2. That must mean that the gradient of the tangent is going to be the negative reciprocal of that. So a reciprocal, if it's a whole number like 3, a reciprocal is just putting it as 1 over 3, because if this was a fraction, it would actually be 3 over 1. So the reciprocal is when you flip the fraction, and it's a negative reciprocal, so it's just going to have a negative sign on it. So we've worked out what the equation, what the gradient of the tangent is. Now every line can be written in the form y equals mx plus c, and it's good to just write this out because this is what we're going to be substituting in. So we know that the gradient is minus a half. So for my tangent, I know that y is minus a half x plus c. Now I'm going to need to try and work out what c is, and c is the y-intercept. Now what is really handy is that I've been given this coordinate which lies on the tangent, so I've been given an x and a y value, so I can use those to substitute into this equation. So when y is 10, x is 5, so 10 equals minus a half times by 5 plus c. So 10 equals, or half of 5 is 5 over 2, which is 2.5. So that would be minus 2.5 plus c. So therefore, c must equal 12.5 because I'm just adding 2.5 to both sides. So now I have the full equation of the tangent. So y equals minus a half x plus 12.5. This is the equation of the tangent. And if you have this equation, you can work out any coordinate on that line. So I need to work out the P, the x coordinate of P. Okay, so P is over here. And now I know that along the x-axis, the y coordinate is always going to be 0. So I know it's going to be x, 0. So when y equals 0, I need to figure out what x is. So let's just substitute that into my equation. So 0 equals minus a half x plus 12.5. And why did I make this so big? Let's change the working over here. So therefore, minus 12.5 must equal minus a half x. And I can multiply both sides by -1 because it just makes my life easier if I'm not dealing with negative subject. So 12.5 equals x over 2, because saying a half of x is the same as saying x over 2. And then I can just multiply both sides by 2. So x must equal 25. So the x coordinate of P is 25. Okay, A, B and C are point on a circle centre O. I'm told that AP and BP are tangents to the circle, and I need to work out the size of angle X. So whenever you have a circle theorem question, you're not going to be given any of the circle theorems. You need to remember them all, and hopefully you've studied them or are at least familiar with them. So what are the clues as to what circle theorems I might be using? Well, I know that we've got tangents to a circle. And what do we know about a circle theorem that involves tangents to a circle? Well, I know that a tangent and a radius meet at 90 degrees. So what I could do, because I've been given the centre O, so I could just draw a little radius here and here. And I know that the radius and the tangent are going to meet at 90 degrees. So there I've formed a kind of quadrilateral. Now, hopefully, when I've drawn this radius here, you can see that I have this kind of thing going on here. So when I've got something like this, that should remind you of the angle at the centre theorem. So angles at the centre are twice that at the circumference. And the way that you can recognize this is that, how is that angle formed? So let's look at this angle here. It's formed by these two lines here. So where's the arc that forms that angle? Over here. Let's do the same with this angle here that's at the center. I extend my lines, and similarly it's also formed by this arc. So that must mean that these would fit the theorem. So I know that I can use that over here. So that leaves me to know that this is going to be 2x, because the angle at the center is twice that at the circumference. So first of all, let's work out what this angle here must be. This is a quadrilateral. Angles in a quadrilateral, wait, I've made it too, oh, I mean that is also a quadrilateral, but I've just made this a little bit complicated. So let's just do the basics. So radius, 90 degrees, 90 degrees. So you've got a quadrilateral, angles in a quadrilateral sum to 360. You know this is 90, you know this is 90, so it's actually going to be 180 that this and this sum to. Also it's yeah, so 180 take away 35 gives you 10 take away 5 is 5, 7 take away 3 is 4, 145 degrees. So we know that this angle is 145 degrees and that this is going to be half of that. So 145 divided by 2 is 72.5. So I know that x is 72.5, and because this is AQA, you don't need to be listing your circle theorems, but it's just good to know them because then you can recognize them. And yeah. Okay, so in this question, I am just going to be multiplying surds, and I need to give my answer in the form something where x is an integer. So generally with questions like this, just do the question, ignore this bit until you actually have something that you're working with. So when I'm multiplying surds and when I'm simplifying surds especially, you're always going to want to rationalize the denominator. So we're always going to have that in the back of our mind. So let's start and see where we get to. We've got 3 root 10 over root 10 times by root 7 over root 2. So let's multiply them. When I'm multiplying fractions, I multiply the numerators across. So that would be 3 root 7, and I multiply the denominators. So that would be root 20. A reminder that when we're multiplying surds, we like bring them together under the same little umbrella. So that's why that becomes root 20. There's a few things we could do. We could first simplify the surd. That might make our life easier, or we could just multiply by root 20. I don't know which. Let's just multiply by root 20. Okay, so you see that you've got a denominator on your surd. Whenever you see, a surd on your denominator. Whenever you see a surd on your denominator, that should ring alarm bells that you need to rationalize. Okay, so rationalize means we don't want a surd part as our denominator. And what we do, if it's a single thing on the denominator, we just multiply by that. And the reason for that is because if we multiply a surd by itself, like the square root of 4 times by the square root of 4 is 4. Because think about it, root 4 is 2 times 2 is 4. Okay, so whenever you're doing a surd by itself, it becomes like its unsurd itself. So that would become 3 root 7 times 20 is 140 over root 400. And root 400 is going to have a nice square root, which would be, well, actually we don't need to write root 400, we would just write 20, because we know that a surd multiplied by itself is its unsurd itself, and that will just make your life easier. So we've got 3 root 14, oh, that should say 140, 3 root 140 over 20. So now what I'm going to want to do, it tells me that I want to give my answer in this form, x root 35. So that's going to be a hint that you're going to want to simplify it, and generally it's going to mean that the surd is going to want to simplify to root 35. So when we're simplifying surds, always write out your square numbers, just as a reminder. It just helps make your life easier. So 140, what numbers multiply to make 140? Well, given that they've given me the clue that there's 35 over here, I could try saying maybe 35 times 4. What does that give me? 5 times 4 is 20. 3 times 4 is 12. Plus the 2 would be 140. So lo and behold, I found a nice number. So that would, if I had root 140, that's the same as saying root 4 times by root 35, which is 2 root 35. So root 140 is the same as 2 root 35. Now this is where I need to be careful, because it's 3 lots of root 140. So my numerator is this, which is the same as saying 3 times 2 root 35 over 20. So just be very, very careful with that bit, because that would then become 6 root 35 over 20. Now it says give it in the form something over 10. So I'm going to simplify by dividing by 2, which gives me 3 root 35 over 10, and that's how we'd get that. Okay, so in this question I'm asked, well, not being asked, but the idea is that I'm going to turn these recurring decimals into fractions. I'm told to work out 0.78 minus 0.32 and to give my answer as a fraction in its simplest form. So generally when we see a recurring decimal, we're going to want to be using the algebraic method of turning it into a fraction. And what I do is I label my, so I've got 2 decimals now, which makes this question a little bit more difficult, but let's take each decimal one at a time. So first one is 0.78 recurring. What I want to do is keep multiplying it by multiples of 10. So if I multiply it by 10, it would become 7.8 recurring. And what I'm aiming for is to get the recurring bit by itself after the decimal point. So that has been achieved. Now I need to do that again. And this is a nice and easy one. So if I multiply by 10 again, I'm left with 100x equals 78.8 recurring. Now, once again, hopefully you can see that the recurring bit matches. So once that has happened, what I do is I circle my powers of 10. So in this case, it's 10x and 100x, and I write them out with the largest number at the top. So I know that 100x is 78.8 and 10x is 7.8 recurring. What I'm going to do then is subtract so that I work out what is left over. So 100 take away 10 is 90x and 78. And this is why this part is so cool, because over here, whatever this is, if this is the same and you're subtracting, it's going to cancel itself out. So I eliminate any recurringness. So that's why I do this whole thing, because then I don't have to worry about the 8 going on until infinity, because I've subtracted it with a multiple. So 78 take away 7 is going to be 71. Therefore, x is going to be 71 over 90. So that is how I've turned my first number into a fraction. Now I do the same with 0.32. So if I multiply by 10, that would be 3.2, and I've achieved my recurring bit on its own. If I multiply by 10 again, that's 100x, and that's 32.2 recurring. Again, I've got the recurring bit on its own. So I write it out neatly. I mean, once you do enough of these, you might not need to, but it's always good because it just means you're taking your time and there's less likelihood of making a mistake. So then we've got 100x take away x is 90x. 32 take away 3 is 29, because the recurring bit will get rid of itself. So x is 29 over 90. So then I've done all of this beautiful work to turn my decimals into fractions. So I know that 0.78 can be written as 71 over 90, and I know that 0.32 can be written as 29 over 90. So I'm subtracting them, so that's what I'm going to do. 71 over 90 take away 29 over 90. So 71 take away 29, 1 I can't do, so that becomes a 6. 11 take away 9 is 2. 6 take away 2 is 4. So that would be 42 over 90. It has asked me to write it in its simplest form, so I'm just going to keep simplifying. I'm going to divide by 2, so 42 divided by 2 is 21, so that's 21 over 45. Now let's see, can I divide both by 3, because it needs to be something that multiplies into the numerator and the denominator. 21 divided by 3 is 7, 45 divided by 3 is 15. So that would be our final answer. Okay, in this question I have been given a quadratic inequality and I'm being asked to solve it. Now, whenever I want to solve a quadratic equation or an inequality, it needs to be equal to or less than or greater than 0. That has already happened, so all I need to do now is factorize. So remember, to solve, you make it equal to 0, or if it's an inequality, less than or greater than. Step 2 is you factorize. So that's the step I'm going to take. So I know it's a quadratic. I'm going to look for factors that multiply to make -6. So 2 times 3, 6 times 1. One of them is going to be negative, and they have to add to make -1. So -3 plus 2 gives me -1, and -3 times 2 gives me -6. So those would be my factors. X minus 3, x plus 2. Now with quadratic inequalities, it's a little bit more complicated than just with an equation. So what I do is I draw a little sketch to help me. The graph of x squared minus x minus 6 is going to have some it's going to have some roots, which is where it crosses the x-axis. And the roots are these things over here. So I make each bracket equal to 0. So x minus 3 is 0. So therefore x is 3. So one of the roots is 3. And x plus 2 equals 0. So therefore x is minus 2. So if you just sketch that, minus 2 can be here, 3 can be here. Your graph is going to look something like this. Now, what we're looking for is where is the graph less than 0? So this is my graph. This is x squared minus x minus 6. And where is it less than 0? Well, this part here is where it's less than 0. So it's in this interval that my x values could be. And so when the graph is less than 0, it's easy because you just write minus 2 is less than x, which is less than 3. If it happened to be greater than 0, that's where it gets a little bit more difficult. And your answer would have been x is less than minus 2 or x is greater than 3. That's where the inequality splits up because it's this part. It's this part here that it is. But our answer is asking us for when is it less than 0, and that is what my range of values would be. The next part says show the solution. 2x squared minus x minus 6 is less than 0. So I know that minus 2 is less than x, which is less than 3. So with inequalities, when you're drawing them on a number line, it's going to be a blank dot if it's less than or greater than, and it's going to be a coloured in dot if it could be equal to that amount. So I put a dot above -2 and one above 3. And then I join them together. I don't know why I did it different colours. And that is all you do for that inequality. Okay, so in this question, I need to work out the value of this mixed number to the power of a third. So first things first, make your life easier by turning this into an improper fraction. So 3 times 8 is 24, plus 3 is 27. So that's going to be 27 over 8 to the power of a third. Now, what does to the power of a third mean? Remember, the denominator is what we're taking it to the root of. So to the power of 1 over 3 is going to be, I want the cubed root. If it was 1 over 2, it would be square root and so forth. And this is what it's to the power of. Because it's 1, it's to the power of 1, which means it's just itself. So what does this actually mean? It means I want to work out what the cubed root of 27 and the cubed root of 8 is. Like all of this to the power of the third is the same as saying this whole thing is to the power of is to the root 3. So then I actually work it out, and hopefully you know your cube numbers. You really need to know them for the non-calculator. A really quick recap would be 1 times 1 cubed is 1. 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, and these are the ones that you definitely 100% need to know. 216 is for 6, 343, but I mean, look them up and memorize them. They're very important. So cubed root of 27 is 3, the cubed root of 8 is 2. So I could either write 3 over 2 or 1.5 because it just says work out the value. Okay, so the next part of the question is saying write 36 to the power of n to the power of 1.5 as a power of 6 in terms of n. So the key is that they've told us to write it as a power of 6. So let's think, how could I write 36 as a power of 6? Well, I know 6 to the power of 1 is 6. I know 6 squared is 36. I know 6 cubed is 216. So it makes sense that I'm going to use this. So instead of saying 36 to the power of n to the power of 1.5, I'm going to replace 36 with 6 squared. So it's going to be 6 squared to the power of n to the power of 1.5. So what do we do when we've got brackets? Well, let's simplify this first. That would become 6 to the power of 2n to the power of 1.5. And we could, just to make our life easier, turn this into 3/2. We don't have to. Depends what works best for you for non-calculator. But once again, we've got brackets. So it's 6. We're going to do 2n times by 3/2. So 2n times 3 is 6n. 1 times 2 is 2. So that would be 6n/2, which would be 3n. So that would be 6 to the power of 3n. Okay, so in this question, I'm told that A and B are similar solid cylinders. So similar means that they are going to be proportional. Their area, length, and volume are all going to be proportional to each other. So the base area of A is in the same to the base area of B as a ratio is 16 to 49. And I need to complete these ratios. So my area ratios, so you've got X, which is your linear ratio. You've got X squared, which is going to be your area ratio. And then you've got X cubed, which is your volume ratio. But we're not dealing with volume, so we don't need to worry about that. So all areas in similar shapes, all types of area, so base area, curved surface area, or total surface area are all going to share the same ratio. So all areas in similar solids share the same ratio. Similarly, all volumes and all lengths share the same ratio. So if the base area to the base area of B is 16 to 14, it's going to be exactly the same for the curved surface area. It will be 16 to 49. Now the height, so remember the area is X squared. So to get a height, that's a linear length. So I'm going to need to square root it. So if the area is X, the length is going to have to be the square root of X. Just because if that's X, yeah. So the height of A to the height of B is going to be the square root of 16 to the square root of 49, which is 4 to 7. So that's how we do those kinds of questions. Okay, so you've made it to the last question. If you've actually watched this whole video the whole way through, you deserve some kind of medal. But let's see what we're doing. So I'm told that a curve has the equation y equals x squared minus 4x minus 9, and the turning point of the curve is at a minus 13. By completing the square, or otherwise work out the value of a. So to find the turning point of any curve, we want to complete the square. So I know that y equals x squared minus 4x minus 9. To complete the square, what I'm doing is I'm just going to look at this bit and try and factorize it. I'm trying to factorize it. So x squared minus 4x, what I do is I halve the coefficient of x, and I put it inside the bracket, and then I square it. So x minus 2 squared, and then I subtract the square of this. So minus 2 squared would be 4, so I'm going to subtract 4. Keep everything else as it is. So minus 9. So I'm writing this in the completed square form. I'm going to brush it up, simplify it. So x minus 2 squared minus 13. So this is the completed square form. Now, to work out what the turning point is, the turning point is where the gradient of the graph is 0. It's where the graph changes direction. So it's going to look like this, or it might look like this. And to work out what the x coordinate is, we need to think to ourselves, what value of x must we put in our equation to make it 0? The quick shortcut version of this is we do the inverse of whatever is in the bracket. That is our x coordinate. So the x coordinate is inverse of this, and the y coordinate is the constant that's left at the end. Okay, so for this, the turning point is going to be 2, negative 13. Therefore, A is 2. For the next part of the question, I am told the turning point of the curve y equals 6x squared, y equals x squared plus 6x plus b has y coordinate 16. So I need to work out the value of B. So the y coordinate is 16, and I need to work out what the value of B is. So let's start by completing the square. Y equals x plus 3 squared. I'm going to subtract 9, and then whatever B is. So this bit here, remember, just like for here, this bit is what my y coordinate ends up being. So minus 9 plus B must be 16. Therefore, B is going to be, if we add 9 to both sides, 25. And that was a very, very, very quick explanation. If you want me to do a quick video going through completing the square and turning points separately, let me know. But I'm quite tired, so that's the end of this. Hopefully it was helpful and you recapped on some of the non-calculator skills, and good luck for Thursday.